Welcome to DriverD Trains. Thanks for stopping by. I'm your host, DriverD. Our conductor and brakeman, Scratchy-C, is currently deep in thought. In my last video, we ran a 30-minute operating session on the D-Saver, my 1-foot by 6-foot HO scale switching layout, running a DCC sound-equipped 4-axle GP40-2 locomotive and modern 50 to 60-foot rolling stock. If you haven't already seen that video, be sure to check it out. In this video, the first in a series, we'll look at how to set up automations in DCC-EX EX Rail to help us run our trains. We'll look at what EX Rail is, some of its features, and how we can use it. Then, in my next video, we'll create the automation together that I use to drive the train off the layout each time I complete an operating session on the D-Saver. We'll look at two different approaches to creating that automation by using timers and sensors, and you'll be able to try the automation yourself on your layout. After that, we'll look at creating a more complex automation that uses two locomotives working together to switch freight cars from one track to another. Be sure to check this video's description for links to my other videos, including my video series on assembling a DCC-EX command station, and my series on using JMRI's Decoder Pro app to control our trains, as well as the various websites and products I mention here. Also, if you are enjoying the videos, please leave a comment and hit the like button. And if you haven't already, be sure to subscribe to the channel. Shuffling all these cars around in the yard is like raking up the autumn leaves. So lace up your boots and let's get started. Creating automations in DCC-EX EX Rail. In my last video, we ran a full operating session on my D-Saver layout. As I mentioned in video number 6A, Meet the D-Saver 1-foot by 6-foot HO scale switching layout, each time I finish an operating session, I notch up the throttle on the locomotive, release the brakes, and sound the horn as the locomotive heads off the layout. After going through this routine manually several times, I decided that while I enjoyed the show, I didn't really feel the need to drive the train myself every time. So I decided to create an automation to do it for me. An automation is a routine or sequence of events that happens on its own following a specified set of instructions without requiring a person to manually perform those actions. Basically, automations allow us to control our trains and layouts as if we were playing a player piano. Automations can be used for many different things. We can use them to control our locomotives, operate turnouts and switches, control lights and signals, play sounds, and control animated features on our layouts, among other things. There are a number of different ways that we can make automations for our model railroad layouts. In my video number 5E, using physical controllers with JMRI and DCC-EX, I demonstrated how to create an automation using computer macros and a Stream Deck controller. We can also program simple development boards like the Arduino to control animations and other features on our layouts. And there are commercially available products to control things like grade crossing signals and track sounds, for example. And we can create various types of automations in JMRI. But for those who run their trains using DCC-EX, the easiest and most useful way to create automations is to use the EX Rail automation module that is built into the DCC-EX EX command station software. That is how I decided to automate running my trains off the layout at the end of each operating session on the D-Saver. And the roll out automation I used to do that is the example that we will start with in these videos. But first, let's have a quick introduction to DCC-EX, EX Rail, and talk a little bit about how to plan an EX Rail automation. Here's what's on the menu in the dining car today. For an appetizer, we'll start with an introduction to EX Rail, the automation component included within DCC-EX, to find out what it is and how it works. For the main course, we'll talk about how to plan an automation in EX Rail, and look at some of the specific EX Rail features, including sequences and aliases, that will help us plan and create our automations. Finally, for dessert, we'll run some trains. All this talk is making me hungry, so take a seat and let's get started. Creating automations in DCC-EX, EX Rail. Part 1. An Introduction to EX Rail. What is EX Rail? EX Rail is a set of DCC-EX features to help us automate our railroads that is included within the EX Command Station software. When Greg Berman first introduced DCC++ to the world in 2015, he said that one of the reasons that he created DCC++ was that he really wanted to automate running trains on his layout, but he couldn't do that with his existing DCC controller. If you haven't already, be sure to check out Greg's DCC++ channel here on YouTube, where you can see his automated 3-loop N-scale layout in action. If you look closely, there's even an automated oil derrick next to one of the structures. I discuss further how Greg designed the DCC++ system in my video number 4X, DCC-EX bonus materials. I'll include a link to the DCC++ YouTube channel in this video's description. When the DCC-EX developers took over the DCC++ project in 2020, updating the automation features of DCC++ was one of the driving factors behind their decision to rewrite the DCC++ Command Station code and create what we now know as EX Command Station and its automation component, EX Rail. The Extended Railroad Automation Instruction Language, or EX Rail for short, is the DCC-EX module for creating or scripting automations for our layouts. EX Rail allows us to write simple automation scripts using basic text instructions that the DCC-EX Command Station interprets and runs on our layout when directed to do so. We don't have to be a programmer or learn complex code to use EX Rail, but some basic understanding of how to create a simple set of step-by-step instructions to obtain our desired results is helpful. We'll look at this together as we discuss how to plan an automation in this video, and then create the rollout automation together in the next video. What can we do with EX Rail? EX Rail allows us to control many different types of automations on our layouts. We can control automations that run our trains. Control switches and turnouts. Operate signals. Display messages on LCD and OLED displays. Play sounds and animate lights and moving features on our layouts, such as crossing arms, semaphores, turntables, machinery, and more. EX Rail includes dedicated commands for these features, as well as ways to create our own commands. There are commands for controlling our locomotives and tracks, signals and turnouts, turntables, sensors, and other inputs, outputs and LEDs, servos, and DCC accessory decoders, among others. EX Rail also includes a number of commands that allow us to control the flow of our automations or the order in which the instructions in our scripts are carried out. There are also conditional statements, such as if, then, else, that allow us to determine whether or not and when our scripts should run. EX Rail can also display messages on our LCD and OLED screens, as well as send information to Y-throttle controllers and JMRI. There are some basic things, however, that we cannot do in EX Rail. For example, EX Rail does not allow us to create or work with variables, although we can create text constants using the alias command. So we won't be doing any math in our EXRail scripts. We also won't be using any for loops, while loops, or counters. EXRail also does not provide a way for any interactive input from the user during the operation of an automation. So, for example, we can create an automation to run our train around the layout a certain number of times, but we can't ask the user to enter the desired number of trips around the layout that they want the train to make when they activate the automation from their throttle. Instead, we have to decide ahead of time how many times to run the train around the layout, or else offer the user multiple options to choose from. One to run the train around the layout once, another to run it twice, and so on. We will use this option ourselves in our examples. It is also important to note that EXRail only works on the Arduino Mega microcontroller or an ESP32 board. The Arduino Uno does not have enough memory for EXRail to run along with the rest of the DCC-EX command station software. We won't go into all the details of EXRail in this series of videos. In fact, we'll barely scratch the surface of what we can use EXRail to do. We'll dig a little deeper in my next video, but you can find information about all the EXRail commands and functions and examples on how to use them on the DCC-EX website. I'll include a link to the EXRail page on the DCC-EX website in this video's description. How do we use EXRail? Scripting or programming in EXRail is done using simple text commands in the myautomation.h sketch, which is part of the DCC-EX EX command station software. For these videos, we will edit this sketch using the Arduino IDE. If you've been following along from my other videos, you may recall that we first created a simple automation using the myautomation.h sketch in video number 4D, Configure DCC-EX Wi-Fi for Station Mode, and then added our locomotive roster to the myautomation.h sketch in video number 5D, using Y-throttle and engine driver with JMRI and DCC-EX. If you haven't previously created a myautomation.h sketch tab, we will do that together in the next video. Although we could create all our automations directly in the myautomation.h tab, eventually we may have many different automations, and having them all in one sketch could get messy and confusing. Just as the different components of the DCC-EX software are written across many different sketches and tabs, we can do the same thing for our automations and put each automation or group of similar automations in its own tab if we like. We'll do this by adding #include statements in the myautomation.h sketch. This will help keep our work organized and clear and make it much easier to update and change our automations in the future. Again, we'll look at how to do this together in the next video. Then, in our myautomation.h sketch, along with any other included tabs, we will list all the various EXRail commands and functions that we want our automations to perform. To organize our work and allow EXRail to understand what we want to do, we will group our commands and functions into collections of related instructions called sequences. We'll look at sequences further in a moment and put them to use when we create our automation in the next video. Once we have created our automations, there are a number of different ways that we can activate or run them. For example, we can use the Y-throttle and engine driver apps to activate our automations. We can also run our automations from the EX Web Throttle app in Google Chrome. And we can use JMRI to run our automations. We can even use hardware controllers like the Stream Deck with JMRI to trigger our EXRail automations. We can also have our automations run automatically so that they are always on, or that they trigger when certain events happen, such as when a turnout is thrown or a button is pressed. We'll explore in detail some of the ways that we can control our automations after we create a few. But now that we have a basic understanding of what EXRail is and how we can use it, let's look at the process for planning out the sequence of steps we want to perform and creating an automation to do them. Part 2. Planning an automation in EXRail. A cake recipe. The example that I will use to illustrate planning and creating an automation in EX Rail is a recipe for making a cake. Creating an automation is like making a cake. The script for the automation is like the recipe for the cake. Our recipe needs to include the ingredients, the order in which to prepare them, how to prepare them, and how to know when to proceed to the next step in the recipe or know when the cake or our automation is done. For example, a recipe for baking a cake might instruct us to start by turning on the oven and then grease the pans before we do anything else. That's because whoever came up with the recipe knows that it takes time for the oven to heat up and that we are going to want to pour our cake batter into the pans as soon as it is ready. Continuing with the cake recipe, we then mix up all the ingredients in a specific order following a specific set of instructions. Once the cake batter is ready, we can pour it into the greased pans right away. But depending on how long it took us to mix the ingredients, we may still have to wait for the oven to finish heating. Finally, after we put the cake in the oven, we have to wait a certain amount of time and then check to make sure the cake is fully baked before we take it out to cool. Our automations will do the same kinds of things with our model railroads. The ingredients for our automations will be our trains, tracks, and sensors, and any other items that we want to control on our layouts. Our automation scripts will then tell EX Rail what to do with these ingredients and in what order. We can also use timers in our automations and wait for specific events to happen, just like when making a cake. For example, we might tell EX Rail to set a timer and then check a sensor or the status of a turnout to see if certain conditions are met before moving on to the next step in our automation, just like checking the oven when the timer goes off to make sure the cake is ready. But a recipe can't just include a bunch of steps we need to take. It also needs to include the steps in the right order and group the steps together in such a way that the recipe is easy to follow. We will also do this with our automations by using EX Rail sequences. EX Rail sequences. As I mentioned before, automations in EX Rail are split up into related groups of functions and commands called sequences. Sequences represent specific parts of our automation that include all the instructions necessary to complete a particular task. Sequences can also trigger or activate other sequences, either because we tell them to or based on other conditions such as the locomotives on the track or the status of turnouts and sensors. Thinking back to our example for baking a cake, turning on the oven and greasing the pan might be one sequence. Mixing up the ingredients to make the batter might be another sequence. And baking the cake in the oven might be a third sequence. Some of these sequences will happen simultaneously, while others need to happen in order, one after the other. We will do the same thing with our automations in EX Rail. For example, we might have one sequence that starts a locomotive moving down the track while blowing its horn. At the same time, another sequence might monitor sensors on the track to determine when the locomotive reaches a certain spot in order to tell the locomotive to stop. Those two sequences can run at the same time. However, a different sequence to start a second train down the track might need to wait until the sequence for the first locomotive ends before the sequence for the second locomotive can begin. For another example, suppose we want to create an automation that drives a train around the layout. To do this, we want the train to start, drive around the layout, and then stop. These are the main steps in our automation. But we also want the locomotive to do other things during the automation, like change its speed, turn on and off its lights, and make certain sounds. We can turn each of the main steps we identified, start, drive around, and stop, into a separate sequence in our automation, with each of those sequences containing multiple instructions, such as turning on the headlight, sounding the horn, or applying the brake. Breaking up our automation into separate sequences will help us plan and organize our script and make it easier to create our automations. For example, thinking about our automation that drives the train around the layout, our automation would include instructions to run the start sequence, then trigger the drive around the layout sequence, and finally run the stop sequence. Now suppose we also want to have a version of the automation that drives the train around the layout twice or 3 times. To do this, we can simply copy our first automation and then have it repeat the sequence to drive around the layout 2 or 3 times. We would still use the same start and stop sequences at the beginning and end of our automation, no matter how many times we want the train to drive around the layout. Breaking up our automation into separate sequences also makes it easier to edit or change how the automation works. For example, consider how we might tell our train to drive around the layout. We could tell the locomotive to drive for a certain amount of time. Or we could use a sensor that can detect when the locomotive passes over a certain section of track and use that to determine when it has completed a loop around the layout. By having a separate sequence dedicated just to driving the train, we can easily edit how it works to instruct the locomotive to drive for more or less time, or switch to using a sensor instead. Or we can have two separate sequences so that we can do both and decide which to use based on which automation we run. Driving a train around the layout may sound like a fairly simple and straightforward automation, but it provides us with an opportunity to look at some of the advanced techniques for creating and managing our automations that will serve us well in the future. Planning all the steps and sequences we need for our automation in advance will provide us with the recipe we need to start writing the script for our automation. We'll take that up in earnest in the next video. To help us keep track of all these sequences, as well as other items in EXRail, such as locomotives, turnouts, and sensors, we will use EXRail's alias feature. Let's take a moment to look at that now. Using aliases in EXRail. All objects in EXRail, such as turnouts, signals, and sensors, must each have their own unique numeric ID. This also applies to locomotives, which must have a valid DCC address, as well as locomotive DCC functions, which have a decoder function number. Likewise, all EXRail sequences must have an ID, which must also be a number. Keeping track of the ID numbers for all these different objects and sequences can quickly become a confusing headache. Fortunately, EXRail allows us to refer to these items by using aliases instead of ID numbers. Alias is an EXRail function that allows us to substitute one value for another anywhere in our script. We can use this function to give the items we want to control, as well as our EXRail sequences, names. For example, instead of referring to turnout 32, we can refer to the siding turnout. Instead of sensor 117, we can refer to the crossing gate sensor. Instead of activating locomotive function 11, we can activate the locomotive train brake function. And instead of running sequence 901, we can run the start loco sequence. Further, in many cases, we don't even need to pick an ID number for the alias. EXRail will do that itself, and we never need to worry about it. It takes a little bit of extra work at the beginning to set up aliases for our automations, but it will save us a lot of time and hassle later on, because if we ever change the ID number for one of the items in our automation, we only need to update the alias once and don't need to update the automation each time we reference that item. So, for example, if we decide to remap the locomotive train brake function to F4, we only need to change the train brake alias from 11 to 4, and don't need to search through our script and change the function every time that we use the train brake in our automation. Using aliases also makes it much easier to plan and follow what is happening in the automation. For example, it is much easier to understand what our automation does when we have sequences called start loco, drive loco, and stop loco, rather than sequences numbered 901, 902, and 903. There are a few limitations to aliases. For example, we can't use spaces or symbols in alias names. Also, we can create any specific alias just once during our automation and can't change it afterwards. So we can't start an automation with the train brake alias set to 11 and then change it to 4 later in the automation. Nevertheless, aliases will be very helpful for planning and creating our automation script, which we will do in the next video. But we've already gone over a lot of information today, so let's take a short break, let some of that information sink in, and then come back fresh and ready to put that knowledge to use. Part 3. Let's run some trains. We have now had a brief introduction to DCC-EX, EXRail, learned what it is and what it can do. We also spent some time looking at how we can use EX rail sequences and aliases to help us plan and create our automations. And we briefly discussed some of the different types of locomotive throttles that we can use to activate our EX rail automations once we've created them. But all this talk is making my head hurt, so let's go run some trains. What's next? Automating a train with DCC-EX EX Rail. In my next video, we'll create together the set of rollout automations that I use to drive the train off the layout each time I complete an operating session on the D-Saver. We'll develop the automations together step by step, and you can try them out for yourself on your layout. We'll use EX rail sequences and aliases to make planning and creating the automations easier. And we'll make 4 slightly different versions of the automations depending on whether the locomotive is pulling 1, 2, 3, or 4 freight cars. Then we'll learn how to activate the automations in the Y-Throttle and Engine Driver apps, the EX Web Throttle app in Google Chrome, and JMRI. We'll create this first set of automations by using timers to control how long the locomotive travels, so we won't need to add any additional hardware to our layout. After that, we'll circle back and add a sensor to the layout and create a version of the automation to use that. Thanks to our use of sequences and aliases, this will be a piece of cake, and we will easily be able to modify the automation to use a sensor. I'll also include all the scripts for the automations in a post on my community page, so watch for that soon. After that, we'll look at a more complex example of an automation that uses 2 locomotives working together to switch 3 freight cars from one track to another. To do this, we'll learn some new ways to control the flow of our automations so that they take turns working in tandem. And again, we'll do this without needing to add any additional hardware to our layout. It's been a long day, but we've sorted all our cars and worked this yard into shape. We can finally take off our boots and put up our feet. But just like the leaves keep falling, trains keep rolling, so I know we'll be back at it again soon enough. But save all that for later. Right now, for some reason, I feel like making a cake. Until then, thanks for watching. Well, Scratchy, did you get some good thinking done? Yes, that's always the best kind. All aboard!